Welcome students, this is our revision lecture of Mathematics class 8, chapter number 6, Squares and Square Roots. Topics which will be discussed in this lecture are meaning of square of a number. First of all, we will review what is the meaning of square of a number. Square number, what do you mean by square numbers? How to check whether a given number is a perfect square or not. Then properties of square number. After that, concept of square root. Then methods to find square root of a number. Let us discuss all these topics in detail. Coming to summary of chapter number 6, squares and square roots. First of all, you should know the meaning of square. Students, you have already learnt about the area of square, which is equal to side into side. So area of square is equal to side square. So we can say that square of a number is the product of the number by itself. Square of a number is the product of a number by itself. For example, 5 square is equal to 25. That is 5 square is equal to 5 into 5, which is equal to 25. Coming to square numbers. What do you mean by square numbers? Squares of natural numbers are called square numbers or perfect squares. For example, in the above case, 25 is the square number and 5 is a natural number. Another example is 16 is equal to 4 square. Here, 16 is the square number and 4 is the natural number. How to find whether a given number is a perfect square or not? Students, all the natural numbers are not perfect squares, so there should be a method to find whether a given number is a perfect square or not. A perfect square can always be expressed as the products of equal prime factors. It means to find whether a given number is a perfect square or not, we need to express the given number into the prime factors using the prime factorization method. Here I have taken two examples. First example is of 16 and another example is of 48. Expressing these two numbers into the prime factors, we will be getting 16 is equal to 2 into 2 into 2 into 2. 48 is equal to 2 into 2 into 2 into 2 into 3. Here, if we have a look, regarding 16, it can be expressed as the product of pairs of equal prime factors. But in case of 48, 3 is left unpaired or 3 cannot be paired. So 48 is not a perfect square number. But 16 is a perfect square number. Now coming to the properties of square numbers. The very first property is a number ending in 2, 3, 7 or 8 is never a perfect square. It means that if a number has 2, 3, 7 or 8 in its units place, then that particular number or those numbers will not be a perfect square numbers like 152, 1028, 6593, etc. Another property is a number ending in an odd number of zeros cannot be a perfect square. It means if a number has odd number of zeros, like in the first case, the number of zeros are odd, that is equal to 1. Second case, number of zeros are 3, that is again an odd number. In third case, the number of zeros are 5, that is again an odd number. So we will say that a number ending in an odd number of zeros cannot be a perfect square. Square of even numbers are even. It means if you are squaring even numbers, the answer will be also even number. For example, 2 square is equal to 4, 4 square is equal to 16. Square of odd numbers are odd. It means if you are squaring odd numbers, result will be again an odd number. For example, 5 square is equal to 25, 9 square is equal to 81. Likewise, another examples can also be taken. Coming to the fifth property, that if a number has 1 or 9 in its units place, then its square ends in 1. For example, 1 square is equal to 1, 9 square is equal to 81, 11 square is equal to 121, etc. Coming to next property, if a number has 4 or 6 in its units place, then its square ends in 6. For example, 4 square is equal to 16, 6 square is equal to 36. If a number has 2 or 8 in its units place, then its square ends in 4. For example, 2 square is equal to 4, 8 square is equal to 64, etc. If a number has 3 or 7 in its units place, then its square ends in 9. For example, 3 square is equal to 9, 7 square is equal to 49, 23 square is equal to 529, etc. Coming to the next property, if a number has 5 in its units place, then its square ends in 5. For example, 5 square is equal to 25, 25 square is equal to 625. Likewise, you can consider another examples also in which a number has 5 in its units place. If a number has 0 in its units place, then its square ends in 0. For example, 10 square is equal to 100, or likewise you can take more examples. Coming to the triangular numbers. Students, what do you mean by triangular numbers? So, the numbers whose dot patterns can be arranged as triangles are called triangular numbers. For example, 1, 3, 6, 10, 15, etc. And if we add two consecutive triangular numbers, we get a square number. Like if I will be adding 1 and 3, these two are triangular numbers, then I will be getting 4, which is equal to 2 square, which is a square number. Another example is 3 plus 6, that is equal to 9. 3 and 6 are two triangular numbers, that is equal to 9, that is equal to 3 square, which is again a square number. 6 and 10, these two are triangular numbers. Together they will add up to 16, and which is equal to 4 square, which is again a square number. So the numbers whose dot patterns can be arranged as triangles are called triangular numbers. For example, 1, 3, 6, 10 and 15. And if we add two consecutive triangular numbers, then we will get a square number. Numbers between consecutive square numbers. Now, another method we have learnt is how to find out the natural numbers between the squares of two consecutive square numbers. Like, there are two n non-square numbers between the squares of two consecutive numbers, that is n and n plus 1. Let us take an example. There are 18 natural numbers between n square and 10 square, that is 2n. Here n is equal to 9 and n plus 1 is equal to 10. So 2 into 9, that is equal to 18 natural numbers will lie between the squares of two consecutive numbers, that is 9 square and 10 square. If the number is a square number, then it has to be the sum of successive odd numbers starting from 1. It means that if a natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. This property we will be using later on in the case of repeated subtraction method, which is a method to find the square root of a number. So coming to this property, if the number is a square number, then it has to be the sum of successive odd numbers starting from 1. For example, 3 square is equal to 9. The sum of successive odd numbers from 1 will be 1 plus 3 plus 5, that is equal to 9. Now, coming to Pythagorean triplet, this is a very important concept, that is Pythagorean triplet. Three natural numbers, if I am taking here natural m, n and p are as three natural numbers, and they are said to form Pythagorean triplet m and p if m square plus n square is equal to p. That is, for any natural number m greater than 1, we have 2m square plus m square minus 1 whole square is equal to m square plus 1 whole square. Now, 2m, m square minus 1 and m square plus 1 forms a Pythagorean triplet. Sum of first n natural odd numbers is n square. Now, if we will observe the pattern, 1 is equal to 1, that is 1 square. 1 plus 3 is equal to 4, that is equal to 2 square. 1 plus 3 plus 5 is equal to 9, that is equal to 3 square. 1 plus 3 plus 5 plus 7, that is equal to 16, which is equal to 4 square. 1 plus 3 plus 5 plus 7 plus 9 is equal to 25, which is equal to 5 square. So we have observed that if I am adding second step, if I will look at second step, so from second step 1 plus 3, that is equal to 2 square, which is equal to 4. If I am adding two consecutive odd numbers, then I will be getting a square number. And these are triangular numbers also, we have studied in the previous property. So if I am adding 3 consecutive odd numbers, I will be getting 3 square is equal to 9. If I am adding 4 consecutive natural odd numbers, then I will be getting 4 square, that is equal to 16. Same is the case with 5 square, that is equal to 25. If I will be adding 5 consecutive odd natural numbers, then I will be getting 5 square, that is equal to 25. Likewise, if I will keep on adding n natural odd numbers, then I will be getting the sum as n square. Now, coming to the very important concept of square root. This concept is very important to find the square root of a number. Basically, we need to do the inverse operation of finding the square. Like, finding square root is the inverse operation of finding the square of a number. And the symbol of this square root is this one. This can be pronounced as square root or under root. Now, 1 square is equal to 1, that is square root of 1 is 1, and that it can be written in symbolic form. It will be square root of 1 is equal to 1 or under root of 1 is equal to 1. 2 square is equal to 4, square root of 4 is 2, that is square root of 4 is equal to 2. Now, in this chapter, we shall take up only positive square root of a natural number. What does it mean? For example, square root of 9 is equal to 3 and not minus 3. Why we are saying so? Because 3 square is 9 and minus 3 square is also 9. But here in this chapter we need to take up only positive square root of natural number. Now, what are the methods, different methods to find the square root of a number? There are basically 3 methods. First one is prime factorization method, and other 2 methods are repeated subtraction and long division method. All these methods we will study in detail with examples. Coming to repeated subtraction method. Suppose we want to find out the square root of 36, and we know that if a natural number cannot be expressed as the sum of successive odd natural numbers starting with 1, then it is not a perfect square. We will use this property and we will keep on subtracting the successive odd natural numbers from the given number till we get 0, and number of times we will do the subtraction, those very steps will tell you the square root of given number. For example, 36 minus 1 is equal to 35. 35 minus 3 is equal to 32. 32 minus 5 is equal to 27. 27 minus 7 is equal to 20. 20 minus 9 is equal to 11. 11 minus 11 is equal to 0. It means starting from 1, I need to keep on subtracting the successive odd natural numbers from the given number till I get 0. If I am not getting 0, it means the given number is not a perfect square. And if I am getting 0, I need to count the number of steps. Here, after till 6 steps, I need to do the subtraction to get 0. So, the square root of 36 will be 6. Here, 6 odd numbers 1, 3, 5, 7, 9 and 11 are being subtracted from 36 to get 0. So, the square root of 36 is 6. That is, in symbolic language, you can write like this. Square root of 36 is 6. I am repeating this method. Repeated subtraction, as the name indicates, I need to keep on subtracting the odd natural numbers from the given number to get 0. But the condition is I need to keep on subtracting the successive odd natural numbers starting from 1. Like here in this case, 36 minus 1 is equal to 35. 35 minus 3 is equal to 32. Likewise, till I get 0, I need to keep on subtracting. And if I will not get 0, it means the given number is not a perfect square. Here, 6 odd numbers are subtracted from 36 to get 0. So, the square root of 36 is 6. I hope this method is clear to you. Coming to prime factorization method. Now, I need to find the square root of 2401 using prime factorization. If it is mentioned in the question, then you are supposed to use that particular method only to find the square root of a given number. Here, after doing the prime factorization, we have come to know that the prime factors of 2401 are 7 into 7 into 7 into 7. And now we need to take only one prime factor from each pair. So square root of 2401 is equal to 7 into 7, that is equal to 49, taking one prime factor from each pair. Two pairs are there, so one prime factor is to be taken from each pair, and you will be getting the square root of 2401 is equal to 7 into 7, that is equal to 49. I hope this method is also very much clear to you. Coming to the long division method, I need to find out the square root of 3249. Here, the very first step to find the square root of a given number using long division method is, first of all, we need to place the bars over every pair of digits starting from the units digit. Here 49 will be under one bar and 32 will be under another bar. Students, you are supposed to keep this thing in mind, that we are supposed to start placing the bars on every pair of digits starting from the units digit only. After that, I need to find the greatest number whose square is less than or equal to 32 here. Such a number is 5. So that is 5 into 5, 25, which is less than 32. So after subtracting, or we need to subtract 5 square, which is 25, from 32, I will be getting 7. Now bring down the pair of digits under the next bar. Under the next bar 49 we have, so it will be written next to 7, and now the new dividend is 749. Double of 5, that will be 10, will be written now. Double the quotient, that is 5 in this case, so it will be 10. And now we are supposed to find the largest possible digit to find the blank along with 10, and which will also be the new digit in the quotient along with 5, such that when the new divisor is being multiplied by the new digit in the quotient, the product is less than or equal to the dividend. Here I will be taking 7 along with 10, and there in the quotient also along with 5 I need to write down 7. So 107 into 7, that will give you 749, and the remainder we will be getting 0. So the square root of 3249 is equal to 57, which is the quotient. Square root of a decimal number. The method is almost same we have studied in the square root of a number, how to find out the square root of a number. Here we are supposed to find out the square root of 31 decimal 36. Now again the steps are same. We are supposed to place the bars after the decimal, starting from the decimal point. Put arrows or bars on the pairs of integers from right to left, as usual we are supposed to do, and on the decimal part from the left to right. Like 36, we will be placing the bars like we are supposed to place on the integers from right to left, as usual we are doing, and on the decimal part from the left to right. Or in simple language, we can say that after the decimal, that is 36, from the after the decimal from the digit which is just after the decimal 36, and before the decimal start placing the bar from the digits which is just forward to the decimal point. So after that, I am repeating it. Starting from the decimal point, put arrows on the pairs of integers from right to left, as usual we are doing, and on the decimal part from left to right. Now after that, find the greatest number whose square is 31 or less than 31. Such a number is 5, and 5 into 5 is 25, which is less than 31, and the remainder is 6. Now this decimal will be shifted along with the quotient, that will be 5 decimal, and the next pair of digits is after the decimal point, and this write the decimal point in the quotient as I told you. So after that, bring down the pair of digits below the next bar, that is 36 will be written along with 6. Now double of quotient, that is 5, which is 10. Double of quotient, which is quotient is 5, so double of 5 is 10. Now after that, I need to find the largest possible digit to fill the blank along with 10 and along with 5 decimal in the quotient, so that which will also be the new digit in the quotient, such that when the new divisor is being multiplied by the new digit in the quotient, the product should be either less than 636 or it should be equal to 636, which is if I will be taking 106 into 6, I will be getting 636, that is equal to 0. So the square root of 31.36 is equal to 5.6. Let us take two examples. One example I have taken first and another example I will be taking later on. A gardener has 1,000 plants. He wants to plant these in such a way that number of rows and number of columns remain same. Find the minimum number of plants. He needs more for this. Students, if the number of rows and number of columns are equal, then number of plants has to be a perfect square. From the question we have noted down this. It means number of plants given are 1,000. The square root of 1,000. Here we are supposed to find out minimum number of plants. He need more for this. It means it is the case of 1,000 plants are already with the gardener, and how many more number of plants will be required so that number of rows and number of columns remains the same. So in this is the case of addition, and for addition and subtraction, as it was being told in the previous lecture or in the last lecture of this chapter, that in case of addition and subtraction we need to use or we need to find the square root of the given number using long division method. So finding the square root of 1,000 using long division method, and we know the procedure, like first of all we need to place the bars and then getting or finding the greatest number which should be less than the number 10, and 3 into 3, that is equal to 9, which is less than 10. So likewise double of 3, 6. Likewise we know that this method, how to solve this. After this, the remainder is 39. In this case we have seen that the remainder is 39. Now it shows that 31 square is less than 1,000. Now as it is a case of addition, like how many more plants will be required. So in case of addition, what we are supposed to do, I need to add 1 to the quotient. Here the quotient is 31. So 31 plus 1, that is equal to 32. So 32 square is equal to 1024. Now the number is to be added to 1,000 to make it a perfect square is, from this 32 square I need to subtract the given number, that is 1,000. So 32 square minus 1,000 is equal to 1,024 minus 1,000 is equal to 24. So the required number of plants are 24. I am explaining this method as it is a case of addition. So I need to use long division method to find the square root of 1,000. Here, first of all, we are supposed to place the bars over every pair of digits starting from the units digit. Then, after that, find the greatest number whose square is less than or equal to 10. Such a number is 3, that is 3 into 3 will give you 9, which is less than 10. After subtracting 9 from 10, I will be getting 1. Then bring down the pair of digits under the next bar, that is 0, 0. Now double of 3, that is the quotient 3, that will be 6. Now I need to write the largest possible digit along with 6 and along with 3, so that when the new divisor is being multiplied by that new digit in the quotient, the product should be less than or equal to the dividend. So here if I will be taking 61 into 1, that is 61. So after subtracting, the remainder will be 39. Now as it is a case of addition, I need to add 1 to the quotient, that is 31 plus 1, 32 square. From this 32 square, I need to subtract 1,000, which I will be getting 24. So the required number of plants will be 24. Coming to the next question, there are 500 children in a school. For a PT drill, they have to stand in such a manner that the number of rows is equal to number of columns. How many children would be left out in this arrangement? Here, this is the question left out in this arrangement. How many children would be left out in this arrangement? So, this is a sort of question of subtraction. So, here again I need to find out the square root of 500 using long division method. Like, placing the bars over every pair of digits starting from the units digit. Then after that, find the greatest number whose square is less than or equal to 5. Here in this case, such a number is 2, that is 2 into 2 which will give you 4, which is less than 5. After that, bring down the pair of digits under the next bar. Under the next bar we have 0 0, so I will be writing along with 1. Double of 2, that is 4. Now along with 4 and along with 2, I need that digit, so such that when the new divisor when they are being multiplied together, the product should be either less than 100 or equal to 100. So if I will be taking 42 into 2, that will give you 84 and the remainder is 16. So therefore, the required perfect square is 500 minus 16. Here in this case, I need to directly subtract the remainder from the given number, and it will be 484, and the square root of 484 is equal to 22. Now, the number of children left out in the PT drill arrangement is equal to 16, because 16 students were left out, and this was the question only. We are supposed to find out how many students will be left out in this arrangement. So, 16 is the answer. I hope students, you are capable enough now to solve the questions or related to this chapter. Now, coming to the homework part, you are supposed to revise chapter number 1 rational numbers and chapter number 6 squares and square roots from NCERT for test. Thank you so much.